Hello everyone, welcome back to my YouTube channel. I am Guru Priya.S of 3rd Sem, pursuing my Information Science course in Sri Venkateshwara College of Engineering. Today I am going to discuss a few topics in the subject Digital Design and Computer Organization. The subject code is BCS 302. The topic is Logic Gates and Basic Arithmetic Circuits. Agenda of this topic: Introduction, Logic Gates, Types of Logic Gates. Types of logic gates has AND gate, OR gate, NOT gate, universal gates like NAND gate, NOR gate, and XOR gate. Applications of logic gates, conclusion and reference. Introduction to logic gates. A logic gates are the building blocks of digital circuits. They perform basic logical functions that are fundamental to digital signal processing. Understanding logic gates is essential for designing complex electronic systems. They are electronic circuits that perform logical operators on one or more input signals to produce an output signal. Logic gates are used to create digital circuits, computer processor, memory device, decoders, encoders, multiplexers. Logic gate symbols: OR, NOR, AND, NAND, XOR, XNOR, buffer, NOT. What are logic gates? Logic gates are electronic devices that operate on one or more binary inputs. They produce a single binary output based on a specific logical functions. The output can typically be in one of two states: true or false. 7 logic gates and 4 useful combinations. Standard logic gates: NOT, AND, NAND, OR, NOR, XOR, XNOR. Preceding NOT gate on one input for NAND, AND, or NOR gates. Types of logic gates. The most common types of logic gates are AND, OR, NOT, NAND, NOR, XOR, and XNOR. Each type of gate implements a specific logical functions and truth table. Understanding each type is crucial for building more complex circuits. AND gate. The AND gate outputs true only if all its inputs are true. If one of the either input is false, it returns false. It is represented by a multiplication operation in Boolean algebra. The truth table for an AND gate shows that the output is true only for the input combination of 1. If inputs like x and y and output is z, if both x and y are zeros, the output is 0. If one of x is 0 and y is 1, the output is 0. If x is 1 and y is 0, the output is 0. If both x and y are 1, then the output is 1. OR gate. The OR gate outputs true if at least one of the inputs is true. In Boolean algebra, it is represented by a summation operation. The truth table for an OR gate indicates that the output is true for any input combination that includes a 1. If inputs like A and B and output is Q, if A is 0 and B is 0, the output is also 0. If A is 0 and B is 1, the output is 1. If A is 1 and B is 0, the output is 1. If A is 1 and B is 1, the output is 1. NOT gate. The NOT gate, also known as inverter, outputs the opposite of its input. If the input is true 1, the output will be false of 0, and vice versa. This gate is crucial for creating complementary signals in digital circuits. If the output is A bar, then the input will be A. If A is equals to 0, A bar will be 1. Negation of A. If A is 1, A bar will be 0. NAND gate. The NAND gate is a combination of an AND gate followed by a NOT gate. It outputs false when all its inputs are true, otherwise its outputs is true. The NAND gate is significant in digital logic because it is functionally complete. If inputs are A and B, if A is 0 and B is 0, the output will be 1 because negation of AND gate. If A is 1, B is 0, the output will be 1. If A is 0, B is 1, the output will be 1. If both A and B are 1, then the output will be 0. Or NOR gate. The NOR gate is the opposite of the OR gate combined with a NOT gate. It outputs true when all inputs are false, otherwise its outputs are false. Like the NAND gate, the NOR gate is also functionally complete. If inputs are A and B, if A is equals to 0 and B is equals to 0, the output is 1. Negation of NOR gate. If A is equals to 1 and B is equals to 0, the output is 0. If A is equals to 0, B is equals to 1, the output is 0. If A is equals to 1, B is equals to 1, the output is 0. XOR gate. The XOR gate is exclusive OR gate, outputs true only when an odd number of its inputs are true. It is commonly used in arithmetic operations such as addition. The truth table for XOR shows that the output is true for the input combination of 0, 1 and 0, 1 only. 1, 0 and 0, 1 only. XOR gets logic symbols. Boolean expression for the output of an XOR gate. Figure A shows XOR gate logic symbol. Figure B shows Boolean expression for the output of an XOR gate. Applications of logic gates. Logic gates are used to build various digital devices, including computers and smartphones. They are essential in creating circuits for arithmetic operations and data processing. Understanding logic gates helps engineers design complex systems efficiently. Feel free to let me know if you need any modifications or additional information. Basic digital logic gates: AND, NAND, OR, XOR, NOT, XOR, XNOR. Conclusion. Summary of the advantages of using CNT and RAM in unbalanced ternary circuits: enhanced efficiency. The combination of carbon nanotube CNTs and resistive random access memory RAM offers high conductivity and fast switching, which improves the efficiency of ternary circuits. Compact circuit design. Ternary logic inherently reduces circuit complexity by using fewer elements to represent data, while CNTs and RAM further minimize size and maximize data density. Thank you. If you like my video, like, share, subscribe.